In today's Design and Make, we're going to feature a special guest who's been working with us on a solid body guitar project.
I'm Jeff Strater, Design and Modeling Software Architect for Fusion 360 at Autodesk. In this video, we'll walk through the design process for this particular guitar body design, show you how I put it together, and show you how you can customize the shape of it for your own use without affecting the overall design, and automatically update the design and the CNC toolpaths. So what you see here is the final result. This is a solid body electric guitar, and so let's look at the very beginnings of the design. So let's go all the way back to the beginning. So a couple important things to remember about designing a guitar is to get the sizes right and the positionings of everything correct. So to help with that, I found some images of a Fender Telecaster, which the geometry of this guitar is kind of based on, if not the actual shape. And using the insert canvas command, I inserted the images and sized them using the calibrate command here, so that you can get an exact size. I have two separate images, one for the neck and one for the body. So that's the basics, and then also the idea of having a center line is very important. So I create one sketch where I create a center line and a couple other reference lines, which we'll see later on, and then insert those images. The next step is to create the actual body itself. So let me get the images out of the way. So here you just need to create the design of the guitar that you're interested in. And you can see here I kept the overall length pretty much the same as a Telecaster, but made a much smaller body with two cutaways rather than the one. Again, the center line is important. And this is just a series of splines defining the body, and in the last segment we'll show how you can change the design easily from here, and everything computes correctly. So this is what I was going after, and then from there it's just a simple extrude. One important consideration here at this point in the design is how thick you want the body to be, and it factors in a couple ways. If it's too thin, you're going to have trouble getting all the components in place without poking through the other side. If it's too thick, then the stock that you'll need is more expensive. So here you can see that my extrude is 1 3/4 inches. And we chose that because it's pretty easy to get 1 3/4 stock, and there seems to be enough room for the components. Okay, the next step is one of the more interesting steps as far as I'm concerned, because it shows the power of both Fusion and then also of the CNC process. It's relatively easy to build an electric guitar that's flat on both sides. I've done this myself just in a shop, but it gets really complicated if you want to have a sculpted top, and this is where Fusion shows its power. So the next step of the design, we'll take it from this flat block to something with some shape to it, which makes it kind of exciting. This ends up being pretty easy in Fusion 360, and it uses the sculpt environment. So we create a form or sculpt feature that's nothing more than starts out as a flat plane, and then I've modified it to give the shape I want. And that's really all there is to it. There's a couple things to consider when you're doing this, however. One is that you've got some components that need to be mounted on here, the main ones being the bridge and the pickups, and you'll want a fairly flat area for those things to sit on. Later on in the series, we'll come back and we'll modify this a bit and show you how to do that, but basically inside the sculpt environment, you can just push-pull on this to change the shape, make it flatter, make it more or less sculpted, whatever you want to do. So after we've created that shape and left the sculpt environment, if you look at the bodies here, you can see Fusion has created a surface body. And then all we do is split the body. So we've selected the main body as the body to split, and this surface body as the splitting tool. And you can see it does that split, and then we follow that with a remove body to get rid of the top, and there you have it. So that's kind of a key part of this version of the design, because I wanted to have something that's a little less boring than just a flat slab of wood. We've got the basic shape, we've got the carved top. So that we're going to go from here to here in this lesson. So the first step, backtracking, will be to cut out a pocket for the neck. In the original body sketch, which was based on the Telecaster body image that I had uploaded, I create not only the outline of the body, but also some geometry for defining this neck pocket. And this is fairly critical because you want the neck to fit tight in this pocket. So some pretty accurate measurements needed. It turns out that the neck is not just a square piece of wood. It actually has some angle to it. So you'll see that I've got this at 1.125 each way, and here at the front end it's 1.0675. We got these measurements kind of by trial and error, but this is fairly important. So the first step in doing the neck pocket is to create a sketch. And in this case, I just projected that geometry in the original sketch. I wouldn't have had to do that. I could have just used the original sketch, but it was easier to sketch on the top plane, which is something I should point out as well. Early on in the design, I defined some work geometry to serve as reference points for later phases of the design. And in this case, this sketch is located on this top plane. Okay, so I have my sketch. Not much to that. It's just projecting those sketch lines from the outline and then do an extrude. So this is another one where some trial and error was involved, where we bought the neck that we're going to bolt to this and did some test runs and did some empirical measurements to try to get it so that the frets are the right height above the body itself. So in this case, it was 0.725 inches. So So now we've got a pocket for the neck to sit in. The next thing that I did here was to create a reference sketch. So based on the neck image that I whole design process is the scale length. This whole design is based on a fender scale, which is 25.5 inches. So I created a sketch with some reference lines not projected, but drawn aligned with the images, so that I knew where the bridge has to go. So this sketch shows that the ends of the saddles have to align about here. The reason I put this in at this point is the next step is to place a couple cavities for the pickups, and I had to make sure that they were in front of that bridge. Okay, so that's the next phase. In the sketch, that's why. So the next phase is to create the sketch that I called the pickup rings. So this actually represents the geometry of the little plastic rings that the pickups set in. And why that's important is because these things have mounting holes in them, and you can kind of see where the holes are. I wanted to make sure when I cut the pockets for the pickups themselves that there was enough room for screws to go into there. So that was that sketch, and then turn that one back on. So there's the pickup rings, and then this sketch was the pickup pockets. And so I designed the pockets so that they would fit inside the outer boundary of the mounting rings, but still have room for those holes. So it was fairly careful geometry there, and then from that is just a simple extrude. Again, the depth is important. In this case, I actually defined a variable pickup pocket depth so that I could play around with it. Ends up being 1.25 inches. So you can see the trick here is to leave enough room in the back so you don't poke through the back, and also have enough room for the pickups. This worked pretty well. And then the final steps for this part of the process is I wanted to put some holes for for mounting the neck. And I started there by modeling, get that out of the way, modeling the plate. So this design, we're going to use the classic Fender mounting plate. So I did a quick model of that, and then that let me create some mounting holes here. Now what we did is, because we were not completely sure we had the locations of those holes exactly right, we just had the CNC machine put some guide holes in. Turned out to be pretty accurate. Doing it again, I think I would actually have these holes go all the way through. The sculpted body, and we've got the cutouts for the neck and the pickups. We're going to go from there to here. So that's our goal today, to design that cutout. So let's back up a bit. What I did when I designed this control cavity is I wanted to position the knobs and switches first. So I simply created a sketch on the back face, and for simplicity of manufacture, I decided to put everything in here. So there's a volume and tone knob, a pickup selector switch, and the output jack. So I created 4 holes of the right sizes. You need to measure the components that you're going to buy and position them. In this case, I wanted things aligned fairly well, so I've got some constraints that hold things together. But having these things in one sketch means I can move things around a bit later on if I want to. So from there, get out of the sketch. You just poke some holes all the way through. Now the next step in cutting out this control cavity is a bit interesting because we're dealing with the sculpted top. And you want to leave enough material in there so that the top is not too thin, and take away enough so that the controls can actually go all the way through. So the main feature here is an offset body. So there's what I've done, and it's just at a specific distance. In this case, it's 3/16 of an inch. You can do more or less, remembering though that you do have to have the components controls actually stick through. So create this offset. The rest of this is some patches and stitches needed to stitch this whole thing together. And again, that just fills in the holes so that we can actually have a good body to terminate to. Next, we want to do the actual cutout. So for this, I created a sketch. Sketch just has one closed spline in it and a couple of circles coincident to the outer edges of this, which is where the supports will go for screwing in the cover. From there, oops, in the sketch again. I actually created this as a separate body, split that body using that surface we just built, remove the top half of it, and then subtract it from the body. So now we've got this nice control cavity here that we know has a constant thickness with the top. The next and final stage is to put a little shelf on this. We're going to use an 1/8 inch plastic as the control cover. So we create a work plane along the outside path of the control cavity, and create a profile sketch here where the depth is a little bit more than 1/8 of an inch. And then finally we sweep a cut around, and now you can see we've got this nice shelf for that thing to sit on. One thing I should point out with this design, with both the pickup cavities and the control cavities, you'll notice that there's something missing here, and that's a way to get the wires from here to here and the wires from here to here. We played around with a number of ways to do this, and in the more advanced series where we design a hollow body version of this, you'll see how we worked around that. But for a solid body, this is a problem. So what I did with the actual prototype I made was to manually drill a hole. So I have a long 1/4 inch bit, and I start from here and can actually go through this whole piece, creating a channel from here to here, and then also the same thing, kind of an angled hole from this face into the control cavity. Let me show you an earlier version. So this was an earlier version of the same design where I tried to work around this problem by positioning the control cavity so that it actually intersected the hole for the pickup. And that works great, but it causes one problem. And that problem is this hole for mounting the pickup doesn't really have much material left. So I thought maybe that solution was a bit too cute and that you'd be better off just drilling the hole yourself. Okay, so what I want to accomplish today is at this point in the design, when I was originally doing it, I had a little panic attack because I wasn't sure. I mean, this is a very thin body, and I wanted to make sure that all the components were going to fit in there and be able to get a lid on it. So spent some time modeling a couple components. I modeled a bridge. Find those. Modeled a bridge. Where did it go? We'll see. Oh, it's right down here. And there's the bridge. And somewhere there's a switch. There's the switch. So I won't go into too much detail on modeling those components. They're basic. They're basic fusion design. But I got the measurements off of the parts themselves. This was after I had ordered them. And the main goal here was to see, A, is there enough room in here for these components and some wires? And then is the pocket deep enough? And you can see that even if we look at it edge on, there's plenty of room for these components to sit in there. So that really was just a safety measure on my part to make sure before we started cutting any wood that the design itself was consistent, and it was. And then the other thing I did is model the bridge that I was going to use. I used a specific bridge. And one of the important things about this design is the bridge I use is what they call a top loader. And a top loader means the strings feed through from this side of the guitar. If you look at a lot of commercially available guitars, they've got holes in the body, like all the way through the backside, and you actually string from the backside. I didn't want that level of complexity in this design. But if you're going to use that kind of bridge, then you'll have to put holes along here for the strings to go through. So I didn't model the whole bridge, I just modeled the mounting plate so that I could position some holes. This is where this gets fun. So say you don't like my design. It's too small, it's funny looking. You can modify it. And there's two main ways you might want to modify it. One is the overall body shape. And for that, if you just edit this sketch, you can make whatever changes you want pretty much. You have to kind of stay away from the neck pocket, stay away from where the pickups are. We'll talk about the control cavity in a minute, but you kind of stay away from that too. But within those parameters, you can basically just drag things around. So you don't want that constraint. You can, so we can make this into more of the original Telly design. by just modifying that. That's kind of ugly, but hopefully you get the idea. You can delete control points, and that helps smooth out the shape a bit. So if you wanted to make more of a single cutaway guitar, you could do that. And you'll notice that my original body was significantly smaller. If it's too small, you want a slightly bigger one. Basic just spline editing. So if you want more of a cutout here, if you want a sharper horn here, making it look sort of more or less polish. I'll get rid of that one. You can come up with some pretty cool shapes, and then just let it go, and there you have a different guitar. Likewise, you might want to change how the sculpting is. So you edit the form feature here, and say you want some extra sculpting on this top, say for where your arm rests. Just do your typical T-spline push pulling. And everything computes from there. The other thing that people might want to change, oops, got a bit of a problem there. Maybe did a little bit too much push pulling there. And do those. The other thing you can change is the control cavity. I have this set up as a 2 pickup volume and tone and pickup switch style. You can get rid of one of the pickups entirely by just suppressing or deleting those features. Get rid of some of the holes if you want a simpler design. Any of that's possible. So go have fun with it, and I can't wait to see what cool designs you guys come up with. Hope you enjoyed this, and be sure to watch the machining videos that accompany this.
Thank you, Jeff. Next time we're going to set up the CAM programming and get ready to put this on our CNC machine.